Okay, guys, lesson 3 is separation of variables. I feel like we've done this a little bit along the way. We definitely did a little bit in the last lesson. Okay, but so we'll get into a little bit more details, probably a little bit more difficult problems than some of what we've seen. But the idea here is separation, right? We're going to want to separate. Equation where all terms can be collected with dx on one side and all y terms with dy can be collected on the other side, then it's said to be a separable equation. Solution procedure is called separation of variables. I also hear integration by separation. Okay, it's that same idea. Okay, and essentially what it comes down to is in the end, we're going to solve and make it y equals. Now, let's look at A. Let's jump right in. dy dx equals 2x over y. You see an easy way to get x's on one side and y's on the other side? Okay, and I'm not saying you have to. I generally, if it works out, end up with my y's on the left, my x's on the right. You know, what do we do in this case? Okay, it's divided by y, so we want to multiply the y over, so then we're going to have y dy. Divided by dx, but we want to get rid of the divided by dx, so we're going to multiply the dx over. And in Algebra 1, we would be writing out all those multiplication steps, wouldn't we? Or maybe probably even in Algebra 2 I would be. In Calc, I'm assuming I can write y dy equals 2x dx, and you got it. Am I safe to assume that, or is that too risky? I feel like at this point, that's the basic algebra. We might mess it up, but... Okay, now, and I will say, some of them that aren't that obvious or that easy, I've been writing out in a couple of steps. If they just, and my first job is usually I'm trying to get rid of the denominators and then trying to maneuver stuff around. Okay, once you have y's and dy on one side, x and dx on the other side, we know we're going to integrate. Okay? What is the integral of y? 1/2 y squared. Integral of 2x. X squared. And then this is an indefinite integral plus c. When we do this, we don't generally leave our answer in this form. And let's see, we're just doing general solution here, right? So our general solution is going to have a c and an answer. They didn't give us any ordered pairs to play in. So we'll have plenty of those as well. One thing, I wouldn't leave that 1/2. How do you get rid of the 1/2? Times 2. Now, if I times 2, y squared equals 2x squared. And this is where I feel like different people do different things. Because I have seen it done where they just leave this as still a plus c. And they don't bother to change anything. I don't think I've ever seen them put 2c, as in that is 2 times c. But I believe, if I recall, what she did is she said, and this is common too, you'll see in the notes, plus c2. As in, what am I saying there? It's just a different c. Okay? So with the idea that that was c subscript 1, so that was like the first c, well, this is 2 times that previous c, so we're going to call it a different c. Okay? Not a huge issue. I mean, the key is you need a plus c there, right? And there's lots of different options here. If we are officially solving for y, what can I write this as? Okay. Y equals square root of 2x squared plus c2. And what'd she forget? Plus or minus. Okay. Unless you have a reason not to put that plus or minus on there. So, I believe when you look in the answer key on this one, yes, here's our y equal version. The other option you could see is because this was a y squared and an x squared, well, here we're thinking conic sections. So it could be a, depending on the sign, circle, hyperbola, ellipse, like one of those type of things. And so the other way that you will often see this one expressed is, I personally would have said y squared minus 2x squared equals C2. Again, I think you could also see it as 2x squared minus y squared equals C2. And this all comes down because we don't have a specific point to use. We don't have a specific solution. Okay? Is that one basic enough? Okay. Let's try example B then. What are you going to do with example B? Okay. Are you doing this all at once? Are we moving the dx and the y squared at once? Okay. If I do that, I'm multiplying the dx over. I need the y squared to go join the dy. So I'm going to have dy divided by y squared equals dx. And keep in mind when we do this, we always want dy and dx to be in numerators, yes? dy and dx should never be in denominators, always make them numerators. So adjust how you need to. I don't know how you guys feel about that dy over y squared. How could I rewrite that? What is a y squared in the denominator? Yeah, so you could, if you need it, y to the negative 2 dy dx. And here's the deal. If it's y squared, this isn't going to be natural log, is it? So that's why I'm rewriting it like that. Did you need to rewrite it personally? I don't know. Not necessarily.
It's not going to be natural log?
Nope.
Why?
Because this is a power of 2, which when I rewrite that as y to the negative 2, you can add 1 to it and divide by the new power. Whereas if it was just a y to the first, and I add 1, negative 1 plus 1 puts me at 0, and that doesn't do anything for me. Okay? So, ready to integrate? What is the integral of y to the negative 2? Okay. Negative y to the negative 1. Add 1 to the power, it's negative 1. Divide by negative 1, well, I just put it as multiply by negative 1, equals, what's the integral of dx? X plus c. If we're going to solve for y, I'm going to change this. I'm going to take away the negative exponent and take it back to the denominator just because I need the visual. So I'm going to rewrite this as negative 1 over y equals x plus c. You can do this in one step, or do you need 2 steps? If I want to get that y out of the denominator, I'll do 2 steps just in case you guys need it. If I want to get that y out of the denominator, I'm going to multiply it, yes? So I'm going to have negative 1 equals y times x plus c. Notice I didn't distribute that, right? Because how do I get y by itself? Divide by x plus c, yes? So this is going to be y equals negative 1 divided by the quantity x plus c. And yes, that's for my answer key answer, is it? Okay. We're ready for C? What are your thoughts about C? Okay. I'm going to multiply the dx to the other side. That just leaves me with dy. But on the other side, I have x times y. So I'm going to divide by y, right? So I'm going to have dy divided by y equals x times dx. The idea here is it's 1 over y times dy. By all means, don't feel like you have to write that. In fact, it's awesome if you can look at dy over y and know exactly where we're going with it. That's why I need you guys to get to that point. Okay, integrate. Okay. 1 over y, that's just y to the negative 1, isn't it? And if I were to try and write that with a power, it'd be negative 1 plus 0, and you shouldn't end up with a 0 power. Okay, so this is natural log of y now. Yep, throw in those absolute value. Integral of x dx. 1 half x squared. Don't forget the plus c. Are we seeing where this problem is going? Is that why we're...
I forgot the plus C.
Can't forget the plus c. Okay. How do I solve this for y? Like, yeah, you see where this is going. Here's our first example where it's popping up. This is similar to what I was talking about in the notes, right? So here's I need you guys to try and follow along what I did in the homework. I'm going to totally re-explain it though here, right? So hopefully it'll make a little bit more sense. But do remember, natural log is base e, right? And so when I have an e in there, I think of it as left, right, middle, whatever your connection is that works for you. So I'm going to say e to the 1 half x squared plus c is equal to y, if you will. Now, I'm curious, how did I do this in my notes? Oh, I have this or that. Oh, because we don't have, this is just general solutions, isn't it?
So we get to be done?
So, now, if you look in her answer key, she does not have it like this. But, and here's what I'm going to say. This is an answer. However, we need to be familiar with how the other one works as well. Okay? Because what's going to pop up on AP? I don't know. And it is, I'm getting the idea that it is common to not necessarily leave that plus c there. Okay? So, we're going to go the OR route. So if we continue with this, y equals e to the 1 half x squared plus c. Okay. Trying to follow the basics here. There's 2 pieces being added in the exponents, right? So I can kind of work backwards here and say that this is e to the 1 half x squared times e to the c. Are we okay with that now? I showed that earlier, right? And then what you will see happen is that they will take that c and rename it. Now, it could be renamed as like a capital C, or what's another variable you also see for constants? And that is k. Okay? I've seen both in these notes. I've seen both in the homework. So just realize, so I'm going to throw this one in as a times k, as in I am renaming that e to the c as the constant k. And the nice part about that is I can rewrite that then out front as k e to the 1 half x squared. Now, it wouldn't have to be k. Okay? A C2 would work, or I feel like a lot of times if that initial C was more lowercase and this is more uppercase, you know, we don't know what these constants are yet, so really, it doesn't really matter, you know. Okay. That gets a little bit trickier when we have to start throwing in a initial condition that gives us a particular solution. That's when it's going to get a little trickier. See, that would have been a lot worse if we got done the one at homework. But, okay. Okay, D. How do you feel about D? I don't know. Do you guys like the y prime? I mean, here's the deal. We're going to have to turn it into dy dx, right? Because otherwise we have to separate it. So what we're doing, we're going to separate this. So I'm going to say this is 4y dy dx. I'm going to go ahead and add the 3e to the x to the other side. So if I rewrite it as 4y dy dx, add the 3x over, so equals 3e to the x, and Pretty easy separation at that point, yes. Multiply the dx over. So 4y dy equals 3e to the x dx. Integrate. Integral of 4y. Add 1 to the power, divide by the new power. So it becomes 2y squared. Integral of e to the x is e to the x. So that's 3e to the x plus c. To solve for y, this is not one, well, I guess I do have two alternate options here. So if we're solving for y, divide by 2. So y squared equals, I'm going to say 3 halves e to the x. You're not going to see c over 2. Okay, you're going to see it stay c, or what you're going to see in the notes is they might change it to a c2. So it's just saying it's a slightly different constant. It's the previous constant divided by 2. Solve for y, we're going to say square root of all this business, plus or minus the square root of 3 halves e to the x plus c2. Okay? Again, most often that's the solution you're going to see. Could have taken a solution and just subtracted these two, and you know, because I don't think I would have done this on my own. So we could have also said 2y squared minus 3e to the x equals c. Depends on the situation of what you need. That's the easiest way to put it there.
Could you just add under the square root 3e to the x plus c divided by 2? Or do you have to make that c2?
Usually you don't see the c in that scenario, where it's like divided by 2. I'm not going to say you couldn't do it, because there's some flexibility with these rules, but I don't feel like that's how I usually see it. How's that for an answer? Now, watch, we'll go into AP review, and then what's going to pop up and go totally against me, but you know. Okay, moving along. Have you started too?
No.
Is the separation pretty easy? Multiply your denominators out there, and the separation looks pretty easy. I multiply the 3y squared over 3y squared dy. If I multiply the dx over, it's x squared plus 1. And I'm going to put that in parentheses and say times dx, because that whole side needs to be multiplied by dx. I'm going to integrate. If you say so. I'm still processing, so. 3y squared, add 1, divide by the new power, y cubed. Integral of x squared, 1/3 x cubed. Integral of 1 is x, and Miles is not forgetting his plus c this time.
I got it.
Two different ways to express this, according to my notes. If we solve for y, what does this look like? Yeah, since it's y cubed, we could say the cube root of 1/3 x cubed plus x plus c. Notice, we don't need a plus or minus here, do we? That's only on your even roots. The other option I see as an option in the notes, if we take this form and going basically more for like a standard form, which like when I did this one over here, this is more of a standard form, I think when I did this one over here, it's more of a standard form. When you have the x's and y's on one side, constant on the other side, no fractions involved. That's kind of a standard form there. If we're going to do that, in this case, we could get rid of the fraction, right? How do we get rid of that fraction of 1/3? I don't want to divide by 3. Oh, okay. Then I'll go with it. We can multiply by 3. Say 3y cubed equals x cubed plus 3x. And if I do that officially, in a way, it's a different constant, right? It's 3 times that previous constant. And then if we put all the terms on one side and the constant on the other side, 3y cubed minus x cubed minus 3x equals the C2. Okay? And I show both. Ultimately, remember, we're preparing for an AP test, right? You see something like this in a multiple choice format. What form are they going to want? I don't know. Okay? Maybe they'll want a y equals form. Maybe they'll want this. And so this is where you need to be versatile, right? Okay. We technically only have 3 more examples. Crazy. Okay. Example 3. Now, difference on this page. Find the solution of the differential equation that satisfies the given condition. Now, notice this problem is x e to the negative t dx dt equals 1. So when that x of 0 equals 1, realize that is saying x of t, right? Well, I don't even want to say, I'll just take that equals out there. But that is x of t. So when we look at ordered pairs in this problem, the input is the t value, so your ordered pair is going to be tx. I also know that because of the way the derivative notation is set up. Just compare it to what do we normally have. We normally have dy dx, right? So you've got your independent variable on bottom, your dependent variable on top. And that's what I've set this up. So t comma x. Just realize, because the struggle for me is I'm flipping the x to the other spot. And that's where I struggle to remember that. Maybe it's just a me thing, but okay. So this ordered pair when we get there will be 0, 1. But normal beginning process. Multiply the dt. Are you going to do something else too, or are you going to wait? Or actually, I could set this up different. What do we know about e to the negative t as is? If I rewrite this to begin with, this is x on top, dx, over e to the negative t goes to the denominator as e to the positive t, dt. That actually makes life a little bit easier there if I show it that way. Okay, I'd rather do that than divide by e to the negative t. I feel like that gets confusing. So now if I multiply it over, x to dx equals e to the t dt. And I am ready to integrate. Integral of x, 1/2 x squared. Integral of e to the t, e to the t plus c. At that point, realize that what we have right here, this is the general solution that we are using on the previous page, right? It may not be solved in final form, but this is the general solution. Now, how do we go about finding the particular solution? Because this wants the particular solution. And in order to do that, we're going to plug in your initial condition. So we're plugging in 0, 1. Let's see. So if I plug into, do you want to try this here? 0, 1. 0 goes in for what? T. And the 1 is going in for x. So 1/2 times 1 squared e to the 0 plus c. 1 squared times 1/2 is 1/2. What do we know about e to the 0? Anything raised to 0 is 1. Solve for c. C is negative 1/2. Okay, so that's kind of step 2. Step 1, general solution. Step 2, you need to find your c value. Particular solution, put them together. So for my particular solution, what did we have? 1/2 x squared equals e to the t plus c, I'm going to say minus 1/2. I would probably at least get rid of the fractions there. If I get rid of the fractions, multiply by 2, we have x squared equals 2e to the t minus 1. And that's the particular solution I have down. Sometimes it's a fine line between, do I express it like this, or do I say x is equal to the square root of that business? Okay? You know, you can go with either or there. Again, comes down to an AP being able to recognize equivalence. So this is our particular solution. Okay? Okay. That's obviously going to be our stopping point. We have 2 more to do tomorrow. And I'm kind of thinking what I introduced earlier comes up more in the homework maybe, where that whole e to the x plus c thing. I think that comes up more in the homework because that was our only notes example. But it comes up several times in homework is what I'm saying. I feel like the homework's going to take you longer than the notes. Like if you're, I feel like it took me longer to do the homework than I did the notes.